Time is 12 o'clock. No,
How are you?
fine. Weather is nice.
When are you coming back to Mumbai?
Middle of
Ma'am,
May.
you are live now. You can start.
Yeah. Okay. Good.
I'll
Are you
turn
able
it.
to? You want the screen? Everything is fine, right? You can see me and the board. Okay. Good evening, everyone, or good afternoon. I hope almost 11 weeks are over and graduation is going on. I think assignment submissions, etc. So we had a live session probably sometime after 3 or 4 weeks after the course started. So before the course assembly, we thought we'll have one more live session. So there are a couple of questions which has been put in the portal, which I will answer. I also want to know if there are, if you have any questions, you can put it on chat and so that I get it and I can start answering them. Purushottam is here and Pratibha, the TAs are here and they will tell me if I'm missing any questions. Okay? Yeah. So the canonically conjugate variable is something which I think is simple to understand, that x, py, y, we call them canonically conjugate if they satisfy the commutator bracket IH cross, right? And y, py equal to IH cross. The other commutator brackets are all zero. X with py will be 0, y with px will be 0, and so on. Okay. Using this, you can also do some kind of a rotation, writing x plus iy or x plus y by root 2 and x minus y by root 2. You can call it as capital X and this is capital Y. Associated to that, you can also write a px, capital X, and a py. Okay. And again, these forms canonically conjugate variables. So this is a simple coordinate transformation where I have done a rotation by 45 degrees. Okay. You could also do another coordinate transformation which you are all familiar, xy to r theta. Right? Where r is the radial coordinate and theta is the angular coordinate. And similarly, you will have px, py. You will be able to write the radial part of the momentum and the angular part of the momentum. Okay. So in the same way, as I argued for you that when you do a rotation, there is a canonically conjugate variable. Similarly, you can show that R and PR are canonically conjugate variables. Their commutator will be equal to IH cross, and so on. So this is something which is very straightforward. Any questions on this? If you have any questions, you can put it on the chat box. And then Purushottam will relay to me on this live portal. Okay, so there was one more question which was asked, where hydrogen atom is actually a nucleus which is heavy with proton and an electron of small m. This is very heavy, okay? So it's a two-body problem. How are we trying to do it as if it is like a one particle physics, like particle in a box we study, showed in the equation for the particle, and here it's a two-body system. How are we trying to study it as a one particle? This also can be done in a very neater fashion that you can write center of mass coordinate. You, instead of working with the nucleus coordinate as R1 and the electron coordinate as R2, you could go to a center of mass coordinate and a relative coordinate. Okay, so these two are equivalent. And you can rewrite the Hamiltonian in terms of the potential energy, which depends only on R1 minus R2. Okay, is that right? Because it is the attraction between the proton and an electron, and that depends on if R1 is the position vector of proton and R2 is the position vector of electron. It depends only on the relative distance, which is R1 minus R2. So this property, okay, which is dependent only on this relative coordinate, essentially helps us to do like a problem of an electron in relative coordinate with this potential. Fine. So this is why it is easy to do and you can assume that the proton nucleus is very heavy. If you don't want to assume, you want to keep the M, then wherever you did the problem, you should replace the mass of the electron by the reduced mass. Okay, so that's the only slight modification you should do. But otherwise, the problem is effectively like a 1D problem, but with a coordinate which is the relative coordinate. Relative coordinate is the difference between those two positions. So in that coordinate system becomes a 1D problem. I hope that answers your one of the other questions. There was one more question on polymatrices.
Ma'am, that side is not visible.
Okay. So let me write again here itself. Can I rub this? Okay. Alright, move the report. Okay. So polymatrices sigma x, sigma y, sigma z are called polymatrices. Is this visible?
Yes, ma'am. Up to that, like matrices. Yeah.
Yeah.
Beyond that, it is not visible.
So that's okay. So polymatrices have this property that square of the matrices, they are 2 cross 2 matrices, okay? So 2 cross 2 matrices, and square of those matrices is an identity. Okay? And you also have sigma x, sigma y, or will give you I times sigma z. And you can formally write this piece in terms of sigma I, sigma j to be using these two properties. You can write it as delta ij times identity plus I times epsilon ijk, where if it is xy, then it will be 1, 2, 3, epsilon 1, 2, 3 is plus 1, sigma k. Okay. So this is a property which it satisfies in general for product of any two components. The sigma I and j are same, then you would get it to be this one. If I and j are different, then you will get this answer and not this. Okay? Now the next question is e to the power of, let's take I theta times sigma z. This was one of the questions. How do I do the exponentiation? So how will you do this? You can rewrite this as 1 plus I theta times sigma z plus I theta by 2 factorial sigma z squared and so on, right? Exponential expansion. So you see that sigma z squared is identity and it comes with a minus theta squared by 2 factorial. Sigma z power 4 is also identity. It will come with theta to the power of 4 by 4 factorial. That expansion will give you a cos theta times an identity. Because this side is a 2 cross 2 matrix, you should have a 2 cross 2 identity matrix. Plus, you can also have an I times sigma z. And then you have a theta, then a minus theta cubed by 3 factorial and so on. The I is anyway pulled out. That will give you a sin theta. Okay? So this is the expansion. This is what you have to know, that an exponential can be written as depends on the parameter theta as cos theta, then you will have a sin theta multiplied by I times. I hope this answers. These things have been discussed in the lectures, and this is the formal procedure. And you may ask why the polymatrices, they satisfy for you the SU2 angular momentum multiplier, right? The angular momentum Jx can be written as half of or h cross by 2 times sigma x. You can use this to solve it. That's fine. There are any more questions on the chat box? Can you cut and paste on this here?
I have done.
What question do we expect in the exam? Same as assignment or different? It's a very good question. What question do we expect? Same as assignment or different from assignment? Where to get the previous year exams questions of NPTEL? I have no idea. We have to find out from NPTEL whether they release the question papers every year in public domain. But questions will be usually multiple choice like every year. It could be multiple choice or fill up the blanks. Okay. And it will have some percentage of questions from your assignments, probably with some modifications on the numbers. So other than that, I don't think I have any more answers to see. Okay? Yeah. Yeah, any other questions you have? You can ask me and I can answer. Anything else?
Nothing on YouTube yet.
Okay. How many are there on the YouTube?
5, 6.
Very less number of people are there.
Yes.
Anything which was on the portal which requires some more additional telling them? Two-body quantum mechanical system, its interaction with electromagnetic field photon simultaneously, how to formulate its Hamiltonian if its interaction with three-dimensional delta function potential to find the spectrum. So the dimension is not important. The two-body system is two particles interacting. The dimension is I can take the particles to move in one dimension along a line, or I can allow the particles to move in a two-dimensional plane or on a three-dimensional space like a cube or something. So the dimension is not important. Effectively, I should be able to write my Hamiltonian as a Hamiltonian where the interaction can be processed like a one particle. Okay. That is what is important. So,
Hello?
yeah, sorry. So the delta function, somehow I got locked out. Okay. So the delta function, three-dimensional delta function problems can also be done. It's not an issue. Is that answering your question, whoever has posted it? See, essentially when you have processes like electron plus proton, they scattering process, okay, becomes an electron plus proton. Instead of doing it like a two-body physics, we can still do that. It's an electron which is under the influence of E squared by 4 pi epsilon naught R, where R is the relative quantity. Okay? R is the relative quantity. So I can still do this problem as a one particle system under the influence of a potential which depends on the relative quantity. The two-body physics can be done as a, but this has nothing to do with whether I am looking at the particle in one dimension, two dimension, three dimension. Is that answering your question? Any other questions?
Nothing yet.
Okay, if there are no further questions, probably in portal, if there were any other questions earlier which you want me to further explain, you can let me know, both the TAs. Otherwise, we can wait for another 5 minutes and close the live. Close the live.
In portal, there are no questions. Like most of them have answered. Yeah.
Okay. Yeah, if you still feel that some things need some more clarification, you can let me know. So 5 more minutes we can wait and then maybe we can close if there are no further questions from any of you who are in the live session. And all the best for your exams. By the way, this course I think allows two summer internships, the best performing two students. I hope Prativa already informed people, right?
Sorry, ma'am.
About the internship.
Ma'am, I couldn't
Some
hear you.
students had asked, hello.
Yeah, ma'am. Sorry.
Some students had asked about the summer internship.
Yes, yes. We had replied on the forum that you can take maximum two.
Two, yeah.
Subset, yeah.
Sure. That's what I meant. Two students are.
Yes.
The best performing two students will be. Any other questions? Any doubts on the poly matrices which I wrote? If you have anything, you can ask me. Okay, so there are no more chat messages from the students.
No, ma'am.
No, ma'am.
Maybe a message can be put on YouTube that the live session will close now, and then we can close it in 2 minutes. Is that okay?
Sure, ma'am. I'm just posting. Only 3 people watching.
I see. Okay, so let's close the live session if you have put the message.
Ma'am, should we
Yeah.
stop the streaming?
Yeah, I think so.
Okay.
If the message has been put that we are stopping the live streaming, we can stop.